So I'm going to be going over a demo complete with a full node, a custom ABCI application, a client, and a small GUI that you can run on your system without installing anything. Just open the project in Gitpod by going to this URL in your browser. The link should also be available in the video description. So the demo application is a simple key value store implemented in Python. We've decided on an arbitrary rule that key values should only increase in length. So if somebody sets the value of a key hello to world, and then later tries to set it to another 5-character word, they'll get an error response from the deliver transaction method. This is just arbitrary logic to demonstrate some kind of rule in our application. The demo consists of 4 components: the Tendermint Core consensus engine, which will run in the background, our customized ABCI application, the key value store, a simple Python client for interacting with the application, which is just sending HTTP requests to the Tendermint provided API, and a small GUI written in JavaScript to show how blocks are being added to the chain. Let's jump into the tutorial. So when you click on the link provided in the presentation and in the video description, you'll get taken to a Gitpod repository with a Gitpod instance with this repository. And so it'll open a VS Code IDE in the browser with everything installed. So it's already got Tendermint installed with the correct version and all the Python requirements. So you should just be ready to start running commands on the terminal. The first command we'll want to run is to start the ABCI application. So that'll be Python app/app.py. Before we run it, we can actually take a look at the application. So you can see it's just uses an object-oriented interface with these methods that we have to implement. That should look very familiar because we saw them in the presentation. So the check transaction method is just making sure that the transaction is properly formatted, so it's able to decode the transaction and split it into the elements that it requires. And then the deliver transaction method is, again, the workhorse of the application, right? So it's decoding the transaction again, making sure that our rule is satisfied, the rule that values for the keys must only increase in length or not, must only increase in length. And so if it doesn't, it returns an error. New values must be longer than the existing value. Otherwise, it sets the value in the key store. In the query, we return the value for a key if it exists. Otherwise, we return NA. And then finally, in commit, we actually write the key value store to disk as JSON. So this is just a very simple API to kind of demonstrate how you can build ABCI applications by implementing these required methods. So if we run the application, it starts running, but it's not actually running yet because we haven't started Tendermint. So Tendermint Core needs to be running in the background in order for the ABCI application to actually begin. So to run Tendermint Core, we'll open a new terminal. And we've provided a convenient script that just kind of runs just a few commands to initialize and set some settings for Tendermint. So you can go ahead and run that, running app restart _tm_node. Okay, now Tendermint Core is running in the background, and so is our ABCI application. Tendermint's ready to receive transactions through its HTTP API. So we can send those just as, you could use curl to send those transactions or wget or anything. We wrote a small convenient script, client.py, that takes some arguments and then properly formats the transaction and then sends it to the correct HTTP endpoint. So you can see how that works by looking at the code client.py here. And the way it's used is we'll open a new terminal and run Python app client.py. And then we'll just do the example that was in the slides. So we'll try to set the key hello to world. And we'll see that we get good responses from the check transaction and deliver transaction method. So code 0, which means everything went okay. And then we'll try to set it to another 5-character word, my name. So now It's also 5 characters, so we get an OK from the check transaction, right? The transaction was properly formatted, everything looked okay up to the point of checking. But in the deliver transaction, we receive an error because that's where we have our application logic that new values must be longer than the existing value. So if we run client get hello, we'll see that the key is still world, right? It didn't get updated to Jared. We set it to something longer though, where it's Coleman. Then again, we get a code 0 response, meaning everything went okay. And if we again try to get the key, we'll see that it was actually updated. Okay, so this kind of demonstrates how to submit transactions to the blockchain and how they're run through your application logic. Now we can also take a look at how blocks are getting added to the blockchain by starting up our small GUI. So first you can cd into the Tendermint GUI subdirectory here, and then run yarn start. So in just a second, the GUI will pop up in a tab in your IDE. Should just take a second to load, and then here we see it. So we see blocks being added to the chain. We're on 155-ish. If we click on one of these blocks, we can see all the information that's in the block. So, you know, there's some identifiers, the current height of the chain, the time the block was proposed, and various hashes. So you see the last commit hash, the data hash, app hash. So these are all used to identify a block. And then we see for each, so our test application here only has one validator, right? We just have a single node in the network. So that's why we just see one validator here that is signing off on all these blocks in consensus. So it's really just consensus with one node in the network. But we can see if we had more validators, we'd see all of them here. So validator 1, 2, 3, and see each of their addresses and signatures for each block that's included in the chain. All right, that's it for the demo. Thanks for watching.